I'll describe how to use an interactive simulation for two immiscible liquids, and the diagram is pressure versus composition, where we'll represent this behavior. And the simulation is located on the LearnChemE site. Here is the link. So let's look at what the simulation looks like. So this is a snapshot, and we're looking at pressure versus the mole fraction of benzene. Pure benzene on the right, pure water on the left. And we have two liquids that are immiscible at higher pressures. As we lower the pressure, we can get vapor forming. This region is all vapor. This region is water, liquid, and both components in the vapor phase. This region is benzene liquid and both components in the vapor phase. And the location of this point is controlled by varying the piston height and by selecting which of these three mole fractions we want to represent. And then on the right here is a bar graph that shows how much, for this point, how much liquid water and how much liquid benzene we have at equilibrium. We can also look at a piston cylinder and show its behavior. So let's look at this simulation to better understand behavior, the phase behavior of immiscible liquids. So if we look at changing the piston height, namely we're raising the piston, you can see the pressure decreased. Now we're in the two-phase region. We have liquid water, and in both components in the vapor phase. If we pick a different mole fraction, now we have benzene liquid phase and both components in the vapor phase. If I keep increasing the piston height, now we have all vapor. Now I can label each of these regions. I can also look at the amount of each phase. So I get in the region where now we have liquid benzene and the vapor of both components. When I get to this point on this line, now we have all three phases. And if I keep changing the height of the piston, the vapor phase decreases, liquid phase increase. And so we can understand how two liquids, each of which will exert its own vapor pressure if it's present in the liquid phase. And the total pressure is, in this case, represented on the y-axis. If we change the temperature, of course, now we change the saturation pressures, the pure component saturation pressures. If we're at this point, pure water, then this is the saturation pressure at this temperature. This is the saturation pressure for benzene at this temperature. And then the sum of those two saturation pressures corresponds to the pressure of this line. So the idea is we can try and better understand how two liquids that aren't immiscible, what their phase behavior will be when we have vapor present, and which phases will be in the liquid phase. And then, of course, at high enough pressures, where we are here, now we only have two liquids present and no vapor.